for support, this is what we're doing. Today, we're doing adding and subtracting. Tomorrow, we have a review in here. And then Friday is our quiz in here. Okay, Monday in here, we're going to talk about equations, but you're not going to be quizzed on that. And we start our final review. Okay, so Tuesday, Wednesday, and Thursday, we have final review in here. And then Friday, we take part 1 of the final in class. So you don't have to get here early. You don't have nothing special. In class. And then Monday, we take part 2. Okay, so as you start preparing for your other, as we start preparing for this final, it'll help you with your final in your regular math class. Same stuff. So in here, I'll actually kind of reteach. So I'll go back over the major topics. In your regular math class, what they're going to do is they're going to give you a packet and allow you to ask questions. So in here, I'll reteach. In there, you can ask questions. Now, obviously, you can ask questions in here too. But I will reteach the major topics before we take our final. Now, I have to go pretty fast because I only have 3.5 days. So I will just touch on the major stuff. I won't spend tons of time going over each little problem.
Do you think if they went and watched your videos again, it would help us?
It might. Like if I talk about something and you're like, I don't remember that at all, I would go back to the calendar and find that topic. And I can even help you find it so you can find the video. Okay, so in your regular math class, a regular Algebra 2 class, today is a review of simplifying, multiplying, and dividing. Okay, tomorrow, Thursday, in your regular math class, you will start adding and subtracting. You'll continue on Friday. So Friday, you have like another little puzzle thing, like you did today. There'll be more adding and subtracting. And then Monday, you will do solving equations. Tuesday, you can ask questions on solving equations, but you also have a review. And Wednesday is your quest, which means bigger than a quiz, smaller than a test. Mine is 70 points. Okay? Now, part of it will be multiple choice, and part of it will be show your work. But with the multiple choice, you also have to show your work. So in case you do all of it right except for one step, I can still give you partial credit. Does that make sense? Hopefully the answers being there will help you. Okay, and then Thursday, Friday, and Monday, we're almost done, guys, is exam review. Now, in your regular class, that exam review will probably just be an opportunity for you to work on your packet and ask questions. So in here, I reteach, and there they give you the opportunity to ask questions. And then your exam is the following week. Okay? So that's what's going on in here. So in here, we're gonna quiz Friday, and then exam the next Friday and Monday. Now, you do not have to come to this class during exam week. Because we have our exam prior to exam week, on Thursday, not Thursday, excuse me, it would be Wednesday morning, first exam, you do not have to be here.
So I can like stay at home and sleep.
Yeah.
You can, if you can get if you can get a ride here for your fourth period exam, then yes, you can sleep in, or you can wake up and study.
Oh.
Yeah, what a good opportunity that is. Yeah.
Or I
So-
go to Waffle House and
Yeah, I goofed. I thought my daughter wasn't going to have to come on Friday. I don't know why. I thought her math exam was next Friday, and she has a milestone. And I was like, all right. I went ahead and bought tickets for us to go to Fantasy and Lights Thursday night. She has an AP Human exam Friday morning. Oops.
Is that the one down in Callaway?
Yes.
It's so pretty.
It is, and we go every year. And we go with our whole family, like our cousins and aunts and uncles and grandma and all that. So it'll be fun.
Setting your car
But
all the way down.
I hate that I did that to her. I bought the tickets too. I mean, it's not like my mom did it, and I'm like, well, grandma did it. No, I did it. All right. So today we're going to do adding and subtracting. So if you guys can take a look at that sheet, we're going to work through these. Now, with multiplying and dividing and simplifying, we just had to write it as multiplication and cancel stuff. But with adding and subtracting, you must get a common denominator. So, when we add or subtract, rational expressions, the first thing we have to do is find a common denominator. Now, factoring is part of that. We may have to factor to determine what the common denominator is. But that's the only way we can add and subtract. All right, so let's look at number 1. Number 1 is 8 over x plus 5 plus x over x plus 5. Well, this is really nice. Because look at this denominator, x plus 5. Look at that denominator, x plus 5. They're already the same. So when they're the same, we don't have to do anything. We just add the numerators. So 8 plus x is x plus 8 over the common denominator was x plus 5. And that's it. Now, we cannot cancel the x's. Why?
Because they're attached to the 8.
Very good. They're attached to the 8 and the 5. There's no multiplication there. So we can't cancel. All right. Number 2. Number 2, we have 10x over x minus 4 minus 6x over x minus 4. All right, once again, this one already has a common denominator. So all we do is combine those numerators. Now with subtraction, you might want to, this only has one term, so it's not such a big deal here. But generally when I have subtraction, I change it to addition and I change the signs of everything in the numerator. Well, this numerator only has one term, so we're not going to mess that up. We know it just means minus. All right, so we look at this, we can actually simplify that. 10x minus 6x is 4x. And that's the simplified answer. 4x over x minus 4. Okay, number 3. We have x plus 3 over x minus 9. And then we have plus 5x over x minus 9. So this one again, when they have the same denominators, it's not too hard. All we have to do is add the numerators. So we get 6x plus 3 over x minus 9. Now, you might see that the numerator has a GCF. If I divided that GCF out, will it help me simplify my problem? It doesn't. If I take that 3 out, I'm left with 2x plus 1. So does that cancel? No. So since it doesn't really help me, there's no real need to do it. If you did it, it's not wrong. It just wouldn't help you. Nothing would simplify. Okay. Any questions about 1, 2, or 3? Now 4 and 5 look a little more complicated, but they're not really. Number 4 has 3x minus 4 over x squared minus 9. And then it's plus 7x minus 3 over x squared minus 9. Well, this is just adding, and they already have the same denominators. So I can just add them. 3x and 7x is 10x. Negative 4 and negative 3 is negative 7. Now, this denominator will factor. But if I factor it, will anything cancel? No. So there's no real need to do that. All right, number 5. We have 2x plus 4 over 3x squared minus x minus 1 over 3x squared. Okay, now this is a subtraction that has multiple terms. All right, do we need to put our phones up so we're not on them? We're going to change all these signs. Change all these signs. And then we're going to put like terms together. So 2x plus a negative x is x. 4 plus 1 is 5. So with the subtraction, I like to go ahead and change it to addition. But then you have to change the signs of everything behind it. Yes, ma'am?
So every time that it's subtraction, you can turn it into...
Yes. Now, nothing else happens. We can't simplify anything else. Okay, so those are when they have the same denominator. They already had a common denominator. So those aren't hard. The harder ones are when the denominators are different. So that's what's going to start happening with the next one. And they're not terribly hard, they're just harder. All right, so number 6. Number 6, we have 11 over 2x. And then we have 4 over 7x. So they both have an x in common. So a common denominator would need to have an x, wouldn't it? Because they both have an x. This one has a 2. And this one has a 7. So a common denominator would have to have both the 2 and the 7. So the common denominator is 2 times 7 times x. Isn't that 14x? Okay, so to be able to combine them, if they don't have a common denominator, that's the first thing we have to do. Now, this one was just over 2 and x, and a common denominator is 2, 7, and x. So what's this one missing? The 7. So we have to multiply it by 7 over 7. Because what's 7 divided by 7? 1. And if we multiply by 1, does it really change the value at all? No. It just changed how it looks. So, this one has to be multiplied by 7 over 7. Now, what was this one missing?
2.
The 2. So, it has to be multiplied by 2 over 2. All right. So, when we put it all together, this is 7 times 11, which is 77.
Wait, are you substituting x for 7 and x for 2?
We're not substituting anything in for x. We're just trying to get a common denominator. So, the common denominator of 2x and 7x is 2 times 7 times x. All three things, the 2, the x, and the 7, all have to be represented in the common denominator. So the first one was missing the 7. The second one was missing the 2. And what is 4 times 2? 8. So this is 77 plus 8 is 85.
So it's like whatever we do to the bottom, we have to do to the top.
Exactly. Yes. All right, so this is a little weirder, isn't it? Let's try number 7. 8 over 3x cubed minus 5 over 12x. Yes, sir.
Would you always multiply to get a common denominator, or can you divide?
You can kind of think of it as dividing. When you look at the denominators, you could say, what number can 2x, or what can 2x and 7x both divide into? And that would be 14x.
No, I'm talking about like, if one of them is like a 2, and the other one's like a 4, could you just like divide them? Like divide the 1 by 2 or something?
That's actually kind of like this one. The common denominator would be the 4. All right, so this one. So when we're trying to find a common denominator, it has to be something that both of these could divide into. So, let's just start with our numbers. If I just gave you this, 8/3 minus 5/12, what would the common denominator be? What's a number that both of these numbers could divide into?
3.
Can 12 divide into 3? It always has to be the bigger one.
36.
Well, then what is
24.
So, 12 is actually the least. The LCD. Now, 36 would work, but what would happen at the end is we'd have to simplify it. 36 would work. It'd just give you an extra step. So let's do that. Let's first look at our numbers. What's a number that both 3 and 12 divide into? And we always want to go with the smallest number. What's the least common denominator? The smallest number that 3 and 12 both divide into is 12. Okay, now we have x cubed and we have an x. So if this has to be able to divide into it, we have to go with the bigger one, x cubed. So really what you're thinking is the smallest number that both numbers divide into. And it's your variable to the highest power. All right, now this was over 3x cubed. And I want to turn it into 12x cubed. So what does this one need to be multiplied by?
12.
4.
Wait,
4.
Because
Because 3 times 4 is 12. All right, so that makes this part 32. Now this one was already 12, so we don't have to change the number part, but this was just 1x, and this is 3. So how many more x's do I need?
2.
2 more. So I need an x squared. An x squared. So this is minus 5x squared. And that's it. That's all we can do. Yes, sir.
For this, is the x supposed to be in front? Stuff?
Normally it is, but because it's negative, it's okay to go in the back.
Okay.
Now, I actually think ones like number 7 are harder than ones like number 8. And number 8 is totally different. So let's look at number 8. Number 8 is 8x over x minus 5 minus 3x over x plus 2. Oh, well, I put it in parentheses. I didn't have to. Okay, so because they're totally different, the common denominator is the product of the two. This one times that one. Because they have nothing in common to start with. One of them is x plus 5, the other one is x plus 2. Because they have nothing in common to start with, the common denominator is just the product of the two. So, on this one, the first one has to be multiplied by the x plus 2. And the second one has to be multiplied by the x minus 5. That's right. Okay. Now, I should have done this a second ago. What was I supposed to turn this minus into?
Positive.
Adding the opposite. There we go. I should have done that to start with. Always do that first step. Now, we're going to have to distribute here, and we're going to have to distribute here. So I get 8x squared plus 16x when I distribute the 8x. Plus, now I got to distribute the negative 3. Negative 3x squared plus 15x. All right, so what is 8x squared? Take away 3x squared? 5x squares. And then 16 plus 15 is 31x. Now, they have an x in common. But if I factored the x out, would anything simplify?
No.
No. So we're done. All right, y'all are really quiet today. Are you quiet because this is easier than I think it is? Or are you quiet because this is harder than I think it is? This is easy. Okay, cool. Good.
I feel like it's really easy to like make mistakes though on this.
Good.
Like, it can be really easy to.
Which hopefully part of your quiz being multiple choice will help with that, because if you make a mistake, hopefully you can catch it before you get to the answer.
Some of it is
Part of the quiz is multiple choice, yeah, part of it.
to like be able to check yourself. How would you do that? You like check your answers. Did you do that with this?
There's not a great check step. There is once we start solving, but there's not really with adding and subtracting.
Okay.
Yeah, I never thought of that. That's kind of a bummer. All right, number 9. Number 9 is the first one that we have to factor to be able to come up with a common denominator. So the first thing I'm going to do, I'm going to actually do it this time. Change. There we go. Step 1. If there's subtraction, change it to adding the opposite. Okay, now to get the common denominator, if your denominator is not factored, you have to factor it first. So do you see that that first denominator has a GCF of x? So it's x times x minus 7. So the common denominator, what is that? The common denominator is actually just the denominator of the first one, x and x minus 7. Because this divides into that and this divides into that. So the first one doesn't have to be multiplied by anything because it was already over the common denominator. Yes, sir.
Do you have to do that before like you multiply?
I would suggest doing that because you can make it more complicated than you need to. So this is just 4. Okay? And then this one has to be multiplied times what? What was it missing?
X minus
The x minus 7. So this becomes negative 3x plus 21. Negative 3x plus 21. So my answer would be negative 3x plus 25 over x times x minus 7. Okay, I'm gonna stop my examples right there. There are 5 on the other side in the other column for you to try. We're gonna go over these before the end of class, and if you're not sure what to do, I want you to ask for help. Okay, so let's go over the last 5. Alright, number 10 is x over 6x minus 5 plus 1 over 5x minus 3. So the denominators are completely different. And when they have nothing in common, the common denominator is where you just list them both. So the first one has to be multiplied by x minus 5x minus 3. The second one has to get multiplied by the 6x minus 5. So the x gets distributed, and it gives us 5x squared minus 3x. The 1 gets distributed, and it makes 6x minus 5. Now, these two are like terms. So at this point, we can go ahead and add them. Negative 3 plus 6 is positive 3. And that's all we can do. Crazy looking answer. Number 11 was 5 over x squared and x plus 3 over x minus 1. Now, they look similar, but they have nothing in common. This is x squared, this is x minus 1, so the common denominator is just the product of the two. So this one was missing the x minus 1. This one was missing the x squared. So this makes 5x minus 5. This makes x cubed plus 3x squared. Well, nothing goes together. There are no like terms, but we can put it in the right order. Start with the highest degree and work our way down to the lowest degree. So that's really all we could do on that one. Nothing simplifies, nothing cancels. You put it together and it looks more complicated than it did to start with.
It's starting to get messy.
Okay, so let's do number 12, and this one, the bell may catch us. This may be the last one we get to do. Okay, so these are totally different again, aren't they? They look similar, but this is minus, this is plus. So common denominator, gotta list them both. So this one has to be multiplied by the x plus 1. This one by the x minus 1. Alright guys, so what we have to do now is we have to distribute on both of them. This makes x squared plus x. This makes 3x plus 1. This makes x squared minus x. And yes, thank you. And 2x minus 2. So we have 2 of the x squares. That makes 4x. And an x makes 5x. And 3 take away 2 is 1. And that's all we can do. Alright, so we'll go over that last 2 tomorrow.